Okay, so let's go over some special derivative rules and the derivatives of trig functions. Now, one thing to note is that all this stuff is on the AP Physics equation sheet. Okay, so if on test day you're all kind of confused about where they are, they're on page 3. Okay, so really the special derivative, aside from the ones that we have already gone over, if you have to find the derivative of anything with e to the x. Oh, sorry. One thing to note, and we'll go over here in a second, is that all of the rules on the formula chart are written using what is called the chain rule. Okay, so I'll write it as you see it on the formula sheet. Get rid of that equal sign real quick. So if I'm asked to find the derivative of e to the ax, the answer is just going to be a times e to the ax. So kind of in general, the derivative of e to the x is just simply e to the x. Okay, that's kind of the great thing about the natural exponent. Here, the a is 1, right? So if I have nothing written in front of my function, it's just simply 1. Okay, so that's one rule. The second rule is the natural log. So if I have the natural log of a times x, well, that's just going to simply be, so I'm taking the derivative of the natural log of ax, it's just going to simply be 1 over x. Okay. We'll get into the chain rule here in a second, and the reason why the a kind of drops out. But also another way to think of this, actually no, because that's an integral rule. Okay. Now, as I mentioned, all the derivative rules on the formula sheet are written using what is called the chain rule. The really chain rule it helps you with derivatives of those composed functions. Okay, so those functions that are like f of g of x, right? So if I define the derivative of f of g of x, okay, the answer is just simply the derivative of f with the g inside of it times the derivative of g of x, okay? Now, the way to think about it is the derivative of the outside times the derivative of the inside. Okay, so this is the derivative. So if I think about it, f is the outside, g is the inside, right? So this is d dx, right? If you want to write it like that, of the outside, right? And then this is d dx of the inside. Right, so if you want to just think about, there's a sentence derivative of the outside times the derivative of the inside. So if we just take do a quick little example here, which I can just make orange a default color there. Okay, so if I'm going to do the derivative of 5x minus 3 cubed, okay, so it's like saying f of x is 5x minus 3 cubed, right? And g of x is 5x minus 3. Okay, and so what I want to do is I'm going to take the derivative of the outside. So I'm going to find what is f prime, right? So that's going to be 3 times 5x minus 3 squared. So what we're really doing on this is that we're treating this as if it was just like a variable like x. Okay. What they actually use in calculus is they'll call this u. Okay, Okay, so this will be called u. And so it's like you're taking the derivative of u cubed. Okay, and then you substitute back in. And so we do g prime of x. Well, the derivative of g prime of x, of 5x minus 3, is just simply 5. And so now I'm going to write what is ddx of 5x minus 3 cubed. Well, I'm going to take the derivative of the outside, which was at 3 times 5x minus 3 squared, times the derivative of the inside. And now I just simplify by multiplying 5 times 3. So what is my answer? So the derivative of 5x minus 3 cubed is simply 15 times 5x minus 3 squared. Okay. So that is the derivative of 5x minus 3 cubed. All right. Now, the last bit of this, we're going to talk about trig functions. Okay. The one thing that you'll see on the formula sheet, there's only 2 trig functions listed. Okay. So you have the derivative of sine. Again, they're writing it as the chain rule. So I have the derivative of sine of ax. And so that's just going to be simply a cosine ax. Okay. And then if I take the derivative of the cosine, again, they're going to write a cosine ax. Right, that's just going to be negative sine ax. Okay. I'm going to do an example talking a little bit more about these, but if you just want a simple one, if I do ddx of sine of x, well, that's just cosine of x. And if I do ddx where a is equal to 1 of cosine x, well, that's just negative sine x. Okay. Okay, so now here's a problem using the chain rule in physics and actually also using trig. Okay, this pops up with a simple harmonic motion. So the equation to find the position of a particle undergoing simple harmonic motion can be found by using the x equals x max cosine omega t plus phi, or phi. Okay, what are the equations for the velocity and acceleration of the particle? And then what are the position, velocity, and acceleration at time t equals 0? Okay, so remember velocity, all right, or sorry, v of t, not v of x. So v of t and so v of t is the derivative of x of t, all right, and a of t is the derivative of v of t. All right, so what we're going to do is we're going to take the derivative of this function twice, okay? And then to figure out the second part, we're just going to substitute in t equals 0 to each one of those, okay? So I'm going to find v of t is going to be ddx or ddt of x max cosine omega t plus phi, or phi. That's the greatest debate, is it phi or phi? Okay, so we're going to follow our chain rule, right? So it's going to be the derivative of the whole thing times the derivative of the inside. Don't forget we still have this x max out here, okay? So we're going to do the derivative of cosine is negative sine, so negative xm sine omega t plus phi, right? And then we're going to do the derivative of the inside. So the derivative of the inside is just simply omega. Okay, because we treat this as a constant, so we treat phi or phi as a constant, and then so we're just really taking the derivative of omega t. And so we just simply rewrite this, so x max omega, right, sine omega t plus phi or phi, okay? And so now we're going to do a of t, which is going to be ddt of what we just found. So we're going to have negative x max omega sine omega t plus phi, or phi, right? And so then we're going to do the same thing. We're going to take the derivative of the whole thing. So the derivative of sine is cosine. So, and then we're going to take the derivative of the inside. So we're going to do negative xm omega. So the derivative of the whole thing would be cosine omega t plus v or phi, whatever you want to call it, times omega. And so that ends up being negative x max omega squared cosine omega t plus v or phi. Okay? And so now what we do is to find the second part, and I'll change the color real quick, because I'm going to write it kind of underneath or near it. Okay? And so if I want to find v of 0, I'm going to take, let's say, negative x max omega, right, sine of omega times 0 plus b. Okay? And so really what happens though is phi is a phase shift, so we'll just call that 0. Okay? And so what we work out, or what we find, is that the velocity at 0 would be 0, because this whole thing right here, right, sine of omega times 0, well, sine of 0 is just simply 0. So when it's at its maximum position, the velocity is just simply 0. Okay? So again, we'll call our phase shift 0. Okay? And so now when I plug it in, I'll do it over here. And so we do a of 0, right, equals negative x m omega squared cosine of omega times 0, right? But the cosine of 0 is 1. So it's going to be simply negative x max omega squared. Okay, so that would be our acceleration. So there's just an example. I know it's a lot of clutter there, but again, using chain rule and also using trig functions. Okay.